Hello, my name is Alex. I will be going over the structure and design of a geometric library that I have designed for a simulator that I am working on. I'm only going to cover the organization and structure of the library. I'm not going to do a line-by-line explanation of how everything works, but I will go over some coding mistakes that I've made, so hopefully you can avoid them. What I assume you know is I assume that you know how to program and that you know how to create objects and functions and classes and stuff like that. I also assume that you know how to do algebra, nothing fancy, but I need you to be able to solve for X or Y. Um, Things that would be nice to know, things that will make your life a lot easier would be vectors. Addition, subtraction, and scalar multiplication is all that you're going to need. No dot or cross products. You really don't need to do that if you don't want to. Also, trig. We will be dealing with circles. You can probably pull it off without trig, but trig will make your life easier. On a structural standpoint, go ahead and create a shape interface. If you're in Java, if you're in C, just the whatever suits your fancy. You probably have a couple options when it comes to C on how to do this. But basically, there's two main functions. One returns what type of shape it is, whether it's a line or a circle, a parabola, something like that. Then there's another function that will return a normal vector for any point on that line or circle or shape or whatever it is. So starting off with the shapes that are in my library, I have a line. There are actually three ways to represent a line. There is the slope-intercept form, the standard form, and the vector form of a line. I use a hybrid system. It's based on the slope-intercept form, except I have a vector to represent my slope rather than a scalar number. This way, when I have vertical lines, I have a slope of either 90 degrees or 270 degrees and not infinity. It makes it easier to recognize vertical lines and then deal with them in a programming context. Next, you have circles. There are two ways to represent a circle. There's the standard form and then there's the vector form. I actually use the standard form and and whenever I need a vector, I just create it right there. It's not that much overhead to calculate vectors for a circle on the fly. So there are three types of calculations that you'll mainly encounter. The first type is when you have just points. Then you have calculations that will involve a point and a shape. And then you have calculations that only involve shapes. This third category where you have only shapes, treat those with respect. Don't rush into them. Take your time. Go on Wolfram Alpha or get a calculator, or dry erase board, or do something. But make sure that you go through and do these right and get the algebra right. You really don't want to have to rework these algorithms more than you have to. But let's start out simple. When you have just points, basically what you're going to be calculating is the distance between them. If you're planning on growing this library, I would suggest having this algorithm return a vector rather than just a regular scalar number. As you do more and more complicated calculations, it's going to be useful to have this as a vector rather than a number. Um, it'll just be easier in the future. So when you're doing calculations that involve points and shapes, it's going to boil down to the distance between a point and some shape. So distance between a point and a line there, I know of two ways that you can do this. One way is based on a odd looking formula I found on Wikipedia. And if you want to see that, you can go there. It's still there. Um, that's based on the standard form of a line. And then there is the way that I was taught in calculus, which involves parallel and normal vectors. I've implemented both of these and they are comparable. So if you don't feel like doing vectors, just go to Wikipedia. The equation's there and they explain how to do it. It's pretty straightforward. Then you have a point to a circle. This is actually rather simple. If you just do a point to point calculation, but you use the center of the circle as your second point. Uh, this doesn't get you on the perimeter of the circle, but if you do want to be on the perimeter of the circle, just subtract the radius from that result, and then you'll be on the perimeter. So, all right, geometric math when you are calculating with only shapes. This is gonna really come down to the intersection of two shapes. So, line intersecting a line. This is very simple to calculate on paper. It is the simplest calculation out of the three, but there are some special cases that you need to look out for when you're programming. The first special case is when the lines are parallel. Your algorithm needs to be able to return some value indicating that they do not intersect. Then there are the two other special cases when you have either a vertical or horizontal line, because this means that your slopes will be infinity or zero. Um, if you divide by infinity, sometimes the mathematics can handle it, sometimes it can. If you divide by zero, your program, well, you know what will happen. Line intersecting a circle. This is fairly simple. Um, just substitute, it's a substitution with system of equations. Substitute the line into the circle, run the quadratic equation, get your roots, and plug them back in. And if you're familiar with systems of equations, this will be pretty straightforward on how to do this. Circle intersecting a circle, this can be really simple or this can be really complicated. Um, if all you want to do is know if the circles intersect each other. That is really easy to find out. You do a point-to-point calculation to figure out the distance between the two centers. If that distance is less than or equal to their combined radii, then the circles intersect. If you want to know the actual points where the circles intersect, that is a little more complicated. I'm not going to go into that right now. I'm going to finish out the overview of the library and then I will come back to how to do that at the end of this video. Closing thoughts and tips. Do yourself a favor, put the quadratic equation in its own function. You're going to use this more than you think, especially if you're going to continue to grow your library. Uh, from a usage standpoint, allow your line class to change its dependent axis. It's easier to do it inside the class than when you're using it to have to create a whole new instance just because you need an inverse. Then lastly, make sure that your circle's normal vectors are based on the circle center and not the origin. Um, there are examples that show um, calculating normal vectors of a circle when it's the unit circle. These examples only work when the circle is centered at the origin. Um, if you're creating this library, it's probably because you have circles that aren't at the origin. So make sure you account for that because that's a bug that can hide for a long time before it shows its face. If you're watching this video, it's probably because you're stuck trying to design your own geometric library. So here are some places that I go when I get stuck. First off, I go to Stack Overflow. If you're watching this video, you've probably been there. Basically, Stack Overflow is a website for professional and amateur programmers to get together to figure out why their programs are breaking. Then there is Stack Exchange Mathematics. It's basically Stack Overflow for mathematicians. It's good for finding algorithms to unusual math problems and things like that. Wikipedia is good for getting an overview and refresher in different mathematical concepts or just concepts in general. There's a lot of information in one place at Wikipedia, and generally it's a good resource. then working with geometry and algebra and stuff like this, I wouldn't do without mentioning Wolfram Alpha. It's a good website and computational engine if you need to visualize what an equation looks like or how it behaves. And so this is the end of the overview of the library. I'm now going to go into calculating the points of intersection of two circles. I did several hours of algebra and searching online, and I came across a thread on Stack Exchange Mathematics where someone actually posted an algorithm on how to do this. So I'm going to go into it and explain at a high level how to go about this. You take your two equations and you subtract them. You get one equation, you expand the binomials, you cancel some things out, you move everything over and solve for y. You'll get a linear equation. You substitute this equation back into one of the circles and you set it up for a quadratic equation. You run your quadratic equation, you get your roots. Then you need to plug these roots back into the line or linear equation that you generated, and then those will give you your points of intersection. The problem with this is it's very tedious to enter into a program. There's a couple places where you have to be careful that you aren't dividing by zero, and if you are, you have to rearrange a lot of things. So to simplify this, what I would recommend doing is making the center of one of your circles the origin and then doing all your calculations based on that. One caveat is before you return your final answer, make sure to add in that circle center. If you're familiar with vectors or if you've worked with vectors before, this is probably something you've done. But as you can see, this is simpler to solve than this is. It takes a couple constants out, and it's just easier. Um, so this is the end of my video. Thank you very much for watching. I hope this has helped you and given you some direction on your own project. So happy coding.